Alright, welcome back. Homework 2, energy transfers, all that good stuff for thermodynamics. This is basically chapter 2 out of Koretsky. I also like to steal a lot of stuff from Shingle and Bowles. They're a mechanical engineering textbook, but I just think how they structure things is really great. But as a mechanical engineer, well, they don't have a lot of the stuff that we as chemical engineers really need. But I do like how they structure their content in their textbooks. So, but in any case, moving on to problem number 4, you have a ceiling fan in a well-insulated room with no windows. Okay, so maybe like an interrogation room or something. That's an awful fan. There we go. Okay, swirling around. Okay. Alright, so you have a ceiling fan, no windows. Okay. Should the temperature of the room increase, decrease, or stay the same? Why? Specifically mention what types of energy transfer are occurring. Okay. Now, it said, and now we gotta get some keywords out of here. It says well insulated, and so how do we draw insulation? Okay, we got that guy. We got the little lines that indicate it's that, and we got our assumption. Okay, so there's our picture. We got our assumptions. We're going to draw our boundary. Our boundary is, the wall. Okay, and so we're going to assume, well, it's well insulated, so that means it's adiabatic. Okay, and I remember reading some article about, the root meaning of adiabatic, and A is without, and okay, with is diabatic, but actually adiabatic is kind of without, transfer and all that is stuff. But anyways, I'm getting off topic. Okay, so it's adiabatic. Let's see here. What else things can we assume? Well, we're going to assume that there's, it's no boundary work. Okay, no boundary work. The room is not changing shape. Okay. Let's see here. So we have no boundary work. Do we have shaft work? Do we have things spinning? Okay, that's a good question. We do have something spinning, but where is it spinning? It's spinning the motor. If you ever look at a ceiling fan, the motor is not in the wall. It's on the fan. So yes, there is work being done, but it's being done within the boundary. Remember, work has to be done across a boundary. And so, we're actually assuming there is no shaft work. Okay? Because there's not movement that's being translated across the boundary. Okay? Let's see here. So, there is no shaft work, technically. There's no boundary work. There's no heat transfer. Okay? It's closed. It's a closed system, so there's nothing flowing in or out. So closed system. Okay. There's no ins. There's no outs. Okay. So closed system. Okay. Let's see here. So then the mass is basically constant. What else do we probably need to assume? Who knows? Okay, so that seems good. Okay, so should the temperature of the room increase, decrease, or stay the same? It should be like all the time. Well, so nothing's happening, but there is. This is moving. It has energy. It has kinetic energy. Now, if we draw our boundary this way, now, I got that cycling of air. Okay. So there is definitely energy happening between the fan and the air. Okay. There is work being done on that air. If I draw my boundary that way. But for the room as a whole, okay, it's not. Okay. But if I draw it this way, well, yeah, it's obvious. I'm adding work to the system. So if I add work to a system, or rather if I do work on a system, not add work to a system, adding work makes it seem like a property. Work's not a property. So I'm doing work on the system. Does that increase its energy or decrease its energy? It increases its energy, okay? So I've got work being drawn here, but if I draw my boundary the original way, it doesn't make sense. It seems like, okay, if I draw the boundary the other way, well, there's no work. But there is work. Where is the work coming from if I draw my boundary here versus here? Well, this isn't on a battery. There's work being done through the electric current. Okay. I have electrical work. I have a power outlet to my fan, and that is bringing in electricity from the outside. And that's being translated into shaft work, which is translated into movement of the air, which is translated to a higher temperature. Okay. But that's really where my energy transfer is going on here, is not shaft work based on my boundary, but electrical work. And maybe you're like, hey, that's a trick question. Well, not really. This is why it's important to think about boundaries, okay? And how we define our boundaries changes how we perceive our system, okay? Because, the energy of the whole universe is staying constant, but the energy of one system is going to impact the energy of the surroundings. Okay, so we always have systems and surroundings, and so how we change our perspective here versus here is going to change our surroundings, what's going in, what's crossing boundaries. And so I don't have any heat transfer, I have electrical work happening. And why does the energy increase? Well, because I am adding work to the system. Sorry, not adding work, I'm doing work on the system. I keep saying it like that. I'm adding energy to the system by doing work on it, okay? I'm adding electric current to my system, which heats it up.